So we are talking about threading and fasteners. Okay, so identification, specifications, and I will show the types of the springs, so which is used kind of threading drawings. Okay, so there are three basic applications on thread. Thread means in Russian there is a rezba, okay, rezbali birikmeler var. Rezbani English as thread deyiladi. So three basic applications on threads. So three things. The first one is to hold parts together. Okay, so if you have one part and if you have another part, so to hold them, we will have kind of threading application. Okay, so we are opening a hole and we are inserting kind of bolt. Okay, so bolt comes with threading here. Okay, and then we are screwing onto here kind of, you know, nut, called a nut. So this one calls bolt in Russian. Okay, so and this one is nut, and in Russian that is gaika. Okay, gaika, nut. Okay, so in here we have threading place, and those thread help you to join two parts together. Okay, so this is one part and that is second part.
А здесь резьба означает резьбу на болте или резьбу на деталях?
Резьбу на болте. Okay, so the threading itself. Okay, so we need to hold parts together. Okay, so it's three applications. The first one is to hold parts together. You can weld it, or instead of welding, you can glue it. You can use a glue, or you can have kind of the threading application. You can have bolt and nuts to hold two parts together. Okay, and the second thing is to provide for adjustment between the parts. So if you have two parts, and then you need to hold these two parts in some distance. Okay, so this distance should not be changed. Like you have to keep like this distance. Okay, so you have to hold it. You have to fix it. You might have here some kind of threaded part, and then here some kind of you know, this stopper, or kind of, you know, the part with screw, okay, with another thread, and when you rotate this one, that will hold this one in this position. Okay, so this first part and second part in this position, you can hold it in this position. So until you rotate this one, without rotation, this one, that will be holded in this position. Okay, so when you rotate, so this will change to this direction or another direction. So to hold parts together, so we are using threading also. So this this part is threaded part. And the third one is to transmit power. So when you want to transfer power, so you might have kind of one part is with threading, one part is threaded, so it's threaded part. So I'm showing the inside of this. So here the thread, sorry. So I will show in next slides. Okay, so to transmit power, how to transmit power with the threading. So it's difficult to do here. And so threading. There is a standardization in the threadings. So let's see the from the history of the threading. Okay, so in 1841, so this person. Okay, so this man, so Sir Joseph Whitworth. So he's the first man who is standardized thread within England. Okay, and he's an English engineer, inventor. Okay, so he did kind of standardization. Why they need kind of standardization? Do you think? So the standardization is needed for to work many companies together, or one company produces some parts and some products, and in order to use that parts or to repair that the product in other country, and or to use many countries products in together, like assembly, for example the train or something like produced in England, but to use this train or the goods in America or in Canada or in other countries, or use some part of the train with other American equipment. So they needed kind of standard parts. Okay, so standardization. So for that purpose, they did kind of standardization. So they set kind of rules for to making that readings, and everyone follow that standard. Okay, so even though within the England until that time, until this time, it was not it was not standardized. So every company has own standard to the, has own style of thread making. So that's why they could not join their parts, their equipment together. Okay, so that's why this guy started to make a standardized, or asked to companies to make one standard within the England, and then they did the kind of standard kind of this one. So in the bottom you can see the shape of the thread, and then they did kind of parameters in the threading, so pitch, and then this side is from this age, so they got 1/6 of age, and this one is small age, and 1/6 again. So this kind of parameters. So and then so the Whitworth made kind of coefficient. So for example, by the age they can got okay, by the pitch. So if the pitch is bigger, so they got the age. So then by this age, they got other parameters, like from this P also. Again, if you put the P here, you got the small age, and radius also, this radius. So they got kind of standard. So so they send this kind of rule and sign from every manufacturer within the England, so who is producing kind of threaded parts or threadings. And then after this one, so within the England, so they started to join every parts with this rule. Okay, so with this kind of threading standard. So and after this one, so there is a good points of threading, standard threading, and bad points also. We have to understand as a manufacturer or as an engineer, we have to understand what's the advantage and disadvantages of the threadings. Okay, so what's the advantage? Advantage is your product price will be cheaper. Okay, because one factory or one producer produces some parts, and then another producer who is using that products in their own product can purchase this one and then easily put and assemble. Okay, instead of producing themselves again, and to produce it again, the producer should purchase the machine for this and train every engineer who is working with that machines. Okay, so that's the extra payment needed. But if you divide the job within the country, so one factory produce some kind of goods and another produce, for example, in the car example, like one factory produces wheels, one factory produces kind of engine, one is doing some kind of elements of the car. Okay, so some parts of the car, and another factory assemble everything together. So you can make it cheaper industry. Otherwise, if every company produce own cars, so they have to produce everything, so that will raise up the price. Okay, so for that purpose, every company should purchase the machines to produce everything in their own factory, and then so everything will be expensive. Every car will be expensive. So that's why they're dividing the job within the country, and then they're trying to standardize every parts, and then so every parts can assemble together easily with using threading. Okay, so that's the way. So then after this one, after the England, US adopted William Seller's kind of threading in 1864, and then 1948 there was an agreement after World War II. So this thing is adopted here. So agreement was made on the unification of American, Canadian, and British screw threads. Okay, so as you know, the trains invented in UK, in England. So and then they sell this trains to America and Canada. So that's why they need to kind of standardize, because otherwise they cannot repair it. So they have to send it again to the UK, England, and then they at that time they repair this train and then send it again, send it back to America. So that was expensive. That was, you know, time consuming. That was very difficult thing. So that's why they did kind of agreement in the threading, and then they produce the spare parts of the train in the America, in the Canada, in every country. So then it was only these countries. Okay, so it was easy to use, exploit the goods, that equipments. Okay, so and then in there was two things. One is UK or America, England standard, and different standard was 1964. Again, after World War II, there was a international organization for standardization, established the international system of metric screw threads. Okay, so ISO started to standardization of metric screw threads. But still, in this time, there was a two system. One is a metric system, and another imperial system. That is two different systems. Okay, so screws are different, two types. One is metric screw, and another is imperial screws. So after this, okay, so in next slide, I will show you how it looks like. Okay, so American, Canadian screws, okay, threads was like this. Okay, so here you can see the parameters. So H, and there is a F. What's the F? F is based on P, everything based on the pitch. So if you have bigger pitch, so you will have bigger F. Again, this height is based on pitch. Okay, so if you have bigger pitch, so you will have bigger height. So on. Okay, so this is seller of American thread. America, Canada, and UK did this kind of threading system. And unified one, that is ISO. Okay, so ISO is this one. ISO is this one. So yes, US adopted is William Seller's one. US adopted is this one. This one, US adopted one. And that is US, Canada, and UK one. UK at that time, it was a British country. So, and this one is ISO one, that is a world one in 1946. So that is ISO metric thread. So nowadays we are using this one. Okay, and So here you can see that many more parameters are here. So there is a radiuses are possible. We can p divided by 4, p divided by 2, so half pitch. And here every parameter you can refer. So what's the main parameter? The terminology. Let's see the terminologies about this reading. So we are using a major or outside diameter. So first of all, let's see what kind of types of threading. So there is two types of this threading. One is a external thread. So in the bolts we are using. Okay, so external thread. We're using in the bolts and screws. And external thread. And another type is internal one. So this one, the second one, that is we are using in the nut in the gaykalada bor shunaqa narsa ichkari tomoni rezbali bo'ladi. So and we have in the threads, you can see that we call this one is root and tegidi joy. So the lowest part is we call the root here, this one root. And this is a side which is, you know, inclined like slope. Okay, so side, and the top is tip point here. That's the crest. We call it a crest. Okay, and this is a depth from the crest up to the root. The distance is vertical distance is we call it depth. So that's a diameter. So we call this one as major diameter. So major diameter. And the from the root, from the lowest point, we can make another diameter. This one is called minor diameter. Okay, so minor diameter. So we have a minor diameter and major diameter. Okay, so. Or we can say in some references, you can see outside diameter. Outside diameter is same thing like major diameter. So major diameter and minor diameter. So that's the root. And then in the middle, there is we call effective pitch diameter. Effective pitch, which is, you know, external and internal. So if you see another part, like if say this part is screw or bolt. Okay, so bolt, and this one is internal part. So say this one is kind of, you know, second one, that is internal one, that is a nut. So when they touch here, and a bolt and nut is touches here in the middle, at the center, we'll have more pressure point. So that point we call effective pitch point. Usually that is in the middle between minor diameter and major diameter. So in the middle. Okay, so that calls effective pitch. So from this point up to this point, we'll have pitch divided by 2, so, or half pitch. We call half pitch. And if you measure from this distance up to this distance, that is a pitch. Okay, so that's a pitch. That's a pitch. Okay, so from here up to here, pitch. Okay, so, or you can make like this. You can start from the crest, from the tip of here and up to this tip. You can get the pitch. Okay, so in Russian that's a shag. In Uzbek that's qadama, rezban qadama. Okay, so okay, so there is an angle, thread angle. This angle. Okay, so this angle is thread angle. So that's the pitch. That's the depth, as I told you. Okay, so those are terminology. And thread axis in the middle of the threaded part. So that's a bolt or screws. There are types of screws, a lot of types. So I will show later on. Okay, so threads for power transmission. In some cases, we'll need to transfer a power, or we need to hold something very heavily, and for that purpose, we are changing these parameters and the shape of the threading. So as I told you, the third application of the thread is to transmit the power. So to hold very heavy thing or to transfer the power. So we use this kind of threadings. So the square thread. So here at the top you can see the square thread or Acme thread. So parameters are like this. So different sizes, different shapes. And you can see here that different slopes. Okay, so the sizes are here is 7, but another side is bigger. To hold part here more, okay. When you transfer, so in order to unscrew the threaded part, okay, yechilib ketishini, buralib ketishini oldini olish uchun gradusini o'zgartirib qo'ygan. So you can see to prevent unscrewing the angles are changed here. So more here is more straight, but here is more slope. Okay, so we call buttress thread. In some cases, you can see the knuckle type threads in the lump. Okay, so in the lump here, you can see its shape is like this. There are no triangle crests. Okay, so it's rounded shape. How do you think? Why is made it rounded? The question, okay?
Для большей площади контакта.
Okay, yes. As the student answered, like we need more area for touching, and another if we do, and also to screw ins and screw out easily. Okay, so we cannot hold this one very by force. We don't need to big force because this is a very light thing, and also to install this one is we need easily install this. Okay, so and easily if that one is broken, so we have to take out easily. So that's why that is made it kind of rounded shape. So if you do with kind of this angle, so it might be it's not easy like this. And another slide. So there is a two types of the threads, right hand side threads and left hand side threads. So here in the left hand side, so in here you can see right hand thread. So when you screw in this direction, this is internal thread, and that is external thread. So this is a bolt, that's a nut, say. If you want to screw into this direction, and to screw in, if you turn the bolt to the right hand side, so then that is right hand sided, okay, right hand thread. Okay, so we are using the characters, okay, so the label like this, RH. So that means right hand thread. Okay, so to take out this one to this direction, you need to rotate counterclockwise. Okay, so that is right hand thread. To go in, to screw in, you need to rotate this one to the right hand side. Okay, so right hand side. So then that is right hand thread. So to go in, okay, so to screw in, if you rotate to the counterclockwise, so that calls left hand thread. Okay, so you can see here the degree of, okay, so the angle of the threadings are different. Here is different. And also we are using nearby the threading okay, so if in the drawings you need to specify it like RH or LH. Okay, a left-hand thread is always labeled like say LH. Okay, and okay. There is a different types of definition in different standards. In ANSI, American, so threaded parts are defined some, okay, drawn as like this way. Okay, so to draw this these threadings as in reality like this is difficult. In the drawings, we are not drawing this one, this kind of style. Okay, so in reality, you will see this kind of threads, but in the drawings, it's very difficult to draw. So that's why we are making a kind of simplification in the drawings. And different countries or different standards like American or UK, they are making a kind of simplification differently. Okay, so in ANSI, so they are making dash lines. Okay, so they're using this kind of dash lines to show the threading depths. Okay, so that's it. The depths of the threads, but the position. So this is a thin line. So you see that thin line, everything, but outside everything here is thick line. So everything outside thick, but inside the thin. So this one is with sectioning comes. So the threading is until the contour it comes. So in the sectioned view. In the view with not sectioned like outside view, so the thread is stop until here. Okay, so thread continue until here. They stop here. So everything threads shown in thin line. Okay, so the depth shown in thin line. Okay, so but in our way, in our case, is looks like this. Okay, so it's until the tip. So we are having a thin line again. This one is thin line. This is section view. So we are continuing. Okay, so we are touching here the contour, but this is outside view. And it's not okay. It's stopped here until this line. This line is thick line. But this blue one is thin line. So this is a thin. But all others are thick here, thick. But this one, center line is thin line. Okay, so same thing happening with the ghost, the meaning, but the outside view is here as thin. We are continuing until the contour. All others here the thick line. Okay, all others except this thread depths, the minor diameter. This is the thin. All others are thick. Here, this is thick line, thick. Even though this one is thick. Okay, so only this one is thin. Okay. And in ANSI, American one. So this is outer view. Okay, so shows inside there is a threaded hole. Okay, so here inside the hole with thread. Okay. With thread, and from outside we can show like this way. Okay, so it's shown with dash, and every side. Okay, but if you make a section view, sectioning, so you can show the hole. So this is a hole shown, and the threading is started from here until here. So here is stopped. Okay, so that's why we have a thick line here like this, and here is no thread here in the wall. Okay, but here is thread, so that's why it's shown with a dash. Okay, so that is in ANSI. But in the GOES similar, but except this the thread major diameter, so major biggest diameter. So here is shown continuous line. Okay, so continuous line. Continuous line. It's not a dash. Continue. That is a continuous line, but thin line. Thin narrow line. And all except to this one. Okay, so this is also thin. Okay, so thin lines we are using blue line, blue color. So thin line. Thin means blue color. Okay, so in our case, so just I'm doing now only the meaning of the blue is thin. Red means thick line. Except, okay, so this one also. This is thin. And all others are thick line. This is thick line. Even this one is thick line. This is thick line. Thick line. Thick line. So this, okay, the threading is until this place. Okay, so until this place, from starting from entrance up to here, that is threaded part. Okay, so the full, we call full thread length. Okay, so there is a run out place, thread run out. So hole again, and from the side, from this view, from here, the view, the threaded depths should shown with a circle, the thin circle like this, but disconnected circle. Okay, so here is not connected. Okay, so it's disconnected. The normally it shows with disconnected circle. So normally it shows like not 1/4 of the circle is not drawn like this way. Okay, and in ANSI there is type of representation is like this way. Okay, this kind of way. That's also thread. So it's easy way to draw thread like this, and then with inclined lines like this is difficult. So that's why they're making like this parallel lines, straight parallel lines in between this kind of line. So that is also represent the threading. And when you see M character in the beginning, so that means metric thread. Otherwise, that is American standard. Okay, so American standard or British standard, like this way. Okay, so there is a types of the American standards A, B, C. Okay, so A and B, and there is a difference. Okay, so I will show. We have a video to introduce this one, American one, but I will show the metric one. So in our course, we are using metric every time. And in our country, we're using metric one, and CIS countries, all European countries are using metric. So that's why we are learning metric threads. So metric thread starts from character M. And there is a types of metric threads form. Okay, so style. Okay, so there's a J or different characters. And the first character, so the mostly we are having just M character and without any J. Okay, and another value, the first value is shows major diameter of the thread. Okay, so if you have M10, that means the biggest diameter is 10 millimeter. So that is 10 millimeter. But when you have a thread, so you have to start from M and multiplied and then pitch. Okay, so the pitch is, as I told you, this distance, small distance between the crests, between the tips. Okay, so the pitch is 1.5 in the millimeter. So everything in the millimeter, in the metric. So 10, okay, the diameter is 10 and pitch is 1.5. So this is a diameter. Okay, so diameter sign, I will put the diameter sign, but you never draw, okay, in a diameter thing. Okay, you never draw diameter sign in this readings. Just instead of this, you need to write M character here. Okay, so line. In assemblies, as we told you that the threadings, the bolts, nuts, and screws we are using to join parts together, right? So that might be temporary join and permanent joint, right? So permanent joint, when we do without having kind of threaded parts, just welding. So if you weld, that will be permanent joint, right? Once you weld it, so you cannot disconnect it. So you have to break it. Okay, so you have to cut it, and you have to remove the weldments. So then you can disconnect it, dismount it. But in case of threaded parts, so that will be a temporary joint. Like you can unscrew it and change your part. You can repair the parts. You can change or you can assemble easily. And once you put the right part there, and just you screw in, and then your assembly is ready. Okay, so it's kind of temporary joint. That calls temporary joint. So that is very good from the exploiting point of view, but it's not good from the weight of the part. Okay, weight of the product. Weight of the product will rise up. That's more expensive also because you have to pay for bolt and nuts, and also when you screw it, that will be slowly. You are joining or you are assembling it more slower than welding. So in the welding, it's very fast. Just you can join it. But once you join it, you cannot dismount it, disconnect, dismount or disassemble it. Okay, so but this one is good from point of view, like you can repair it sometimes, and for repairing, no need to breakage. Just screw out and then put the new part and then screw in again. But you have to pay it. You have to pay extra payment. And here the difference of the screw and the bolt joint. So here, when you have a part, so that is okay. So upper part, that's lower part. So here, this one is upper part, and that's the lower part. Lower part. So we are joining in here with bolt. So this is a bolt. That's a washer. We call a washer, or the bolt might come with washer joined together. So some bolt caps has kind of washer type here, and nuts also. This is a nut. So in Russian, that's a bolt, and this one is a gaika. Okay, so that's a gaika. And threaded element is from here until sorry, threaded side is here from started from here. So there is an inner element until here. So and nut also has internal thread, and so holding this bolt and nut together, so holding these two parts together. Okay, so pressing these two things and hold these two parts together. So these threads are trying to hold these two parts together, and the part has bigger diameter than the bolt diameter. So this is a part. So diameter is bigger than the bolt. So that's why in this hole, you can insert this bolt easily. So you are not screwing the bolt. Okay, so you are screwing the bolt only to the nut. So part has bigger hole. So there are no threading on the part. Just in the wall of the hole, inside the hole, there are no screws. Okay, so no any threads. Just you're inserting the bolt inside to this hole, and then from another side just you're screw down this the nut to the bolt only. But in case of the screw, so that's the screw. So and there is a counterbore. Okay, so counterbore hole inside, and we are putting inside this hole, and the upper part there are no screws, so that's why you can see this line. So that line means there are no screw, no threaded wall in the hole, just only the hole. That's the hole of the part, and that is also the hole, inner hole. There's a hole to make the screw cap hidden. It's made it like this hole, and we insert a screw until touch to this. Let's make this another color. This green thing. Okay, so there is another part. So here in green part, okay, so lower part, we have a thread. So then the screw thread has a thread here. I will show the thread, please. Is using purple color. So the thread of the screw is here until here. Okay, so we screw in to the part. Okay, so this part, lower part, holding the two parts together with using a screw. Okay, so we are screwing this screw, set screw or hex, I think hex screw. This screw inside this lower part is joined here in this place is this whole, okay, touching and then screw in inside and holding this part together. Okay, so this screw only, so there are no nut. So the basic difference of screw and the bolt and nut is the bolted joint is this. Okay, so this is screw joint, that's bolt joint. Okay, so we are not having a nut, just we are screwing to the part, so lower part, and the screw is holding this upper part all together. Okay, so because of this, lower side of the part has a screws, but upper side there are no screws, just it's made at bigger diameter. So bigger diameter here is bigger diameter. And okay, understand. If you have any question, just please ask. And to show that in the assemblies, to show the difference of the parts, so to show the parts are made as a separated part, we are having different direction of the section line. Okay, so this kind of sectioning line, hatching are has different direction. So one direction means one part, another direction change it, so second part. This is first part and second part. So here also same, this is the first part and that's the second part, okay, to show this. And also there's a rule, the screws and bolts and nuts and any joint to make this kind of temporary joint things are not sectioned. Okay, so here, even though this front one part, upper part, lower part are sectioned, but the screws and the bolts are not sectioned. So that's a rule. Because of those are common things, common parts, so that's why it's not sectioned. And yeah, what's the next? Yeah, the main difference, there is a studs also possible here. The bolt has a head on the one end. Okay, so this is a bolt joint, so this is a head. Is passed through the clearance holes in 2 or more aligned parts. It might be 2 or more parts. Okay, so here it might be different, another part. So many, 3, 4, 5 parts. And it's threaded on the other end. Okay, so here the threaded starts from here until end of here. So the threaded line is the minor diameter is thin line. And receive a nut to tighten. So we have a nut here to tighten everything inside this area and to hold the parts together. The cap screw is this one. Okay, so cap screw is similar to a bolt, except is often has greater threaded length. So often this length, so threaded length is bigger. So this length is bigger. So this is a threaded area. Okay, so the threaded length is bigger than the bolt thread, because here we have a nut, but here we don't have a nut. It might be the different softer material than the nut, so that's why we need more length here. Okay, and the cap screw is screwed on the with a wrench. We're using a wrench here to rotate or to screw in. But for the bolt also we will need a wrench. And here, but you can use a hand, and after for more to get more tightness, you need the wrench again. The stud is a steel rod threaded on one or both ends. When we have and sometimes when we have no room, what we do is we are having no room for the wrenching. We'll have only the rod like this. Okay, so kind of threaded from the both ends. So threading area is here, and in 2 ends is threaded. So we are screwing inside this rod, and we are putting this part without threaded area. Okay, so with hole without threaded area, just putting here. Okay, so in the rod, and at the top we are putting a kind of a nut onto it, and then okay, so tighten up. Okay, so screw in again the nut. So okay, so it's joint in here, and from upper side the nut. There are no cap. Okay, so this nut works as a cap. Okay, and okay, so that's, we call it, that is a stud. Okay, so there is a the heads of the screws are different, a lot of types, a lot of standardized many types. So do not section bolts, nuts, screws, and similar parts when the drone assembly, because they do not have interior detail then needs to be shown. Okay, so we are showing just from outside. We are not showing inside, so we are not making a sectioning. And here you can see the flat one, round one, binding one. So flat one is from outside is flat, so that's why that calls a flat. in order to make easy to hold or to set on the table, to put somewhere, to install somewhere, so we are making kind of flat top or rounded one, the binding one, truss one, filisser one, pan one. So here it looks like a pan. Oval one, in indented hex unslotted one, or washer slotted, so it's like this, so minus from the side. And if you see from this, that's hexagon shape, this and that. And that calls Phillips one we're using in the computer boxes. The wood screws and metallic ones are different. So in the metallic screws, the pitch are smaller. Okay, so if you see the pitch, the distance between the pitch, okay, so not the between the pitch, between the tips, okay, between the crests, we call it pitch, right? So that pitch value is smaller in the metallic threadings, but in the wood one, those pitch is smaller, and the shape is different. Different. Okay, so here you can see the wood screws and parameters. So the wood screws has this shape, and the threaded length is 2/3 of the L. Okay, so the length. Okay, so there are a lot of types of the wood screws are possible. So here you can see the standard bolt parameters. So the bolt cap is made it, the mostly made it standard one is a hexagon shape, and the mostly that this size is 1.5 times of the D diameter. Okay, and so the nut is the mostly that's made like 0.875 times of the D, and that is 0.67 times of the D. And so you have to follow this kind of parameters and drawing standards. So the simplified version of the view is this one, so threaded thing. So, but that is less simplified, and that is, as I told you, the ANSI standard that is made it kind of dash line. But in our cases, that is a similar, but this one is continuous line. But here is you have to continue until the touching the tip. Okay, so that is the fasteners. We call this one a stop bolt to hold the part inside, and the most we're using this one is in to hold non-metal parts like wood parts, and this is also wood part holding. So it comes with a neck here, and there is a wing nut you can see is and thumb screw and U-bolt, okay, I-bolt, U-bolt, and hook bolt. We're using to hold parts in some distance. Okay, so here one part here, so and we put some kind of some part element here, another part, and we might set up something to hold two parts together, or to join two parts, like so. This is common types of fasteners. Okay, so springs are classified as helical springs or flat springs. So in here on left hand side you can see the helical springs, and I have to draw them in the drawing, and on right hand side flat springs. Okay, so those are. So when we use a helical springs, so as we told, the helical springs is designed to store energy when it's pressed, and then that is deflect or return the equivalent amount of energy, and okay, so to deflect the energy when you have some force, and then that will try to return its own shape. Okay, so initial shape when you off that force. Okay, so we use this one in this suspension of the car. When we use a helical springs, when we have longer height is bigger, but the area is smaller. So area is the cross section is small. Okay, so cross section of, if you see from this side, so cross section is smaller, but the height is, we have a bigger height. But when we have small height, so height is smaller. So height is smaller here, comparing to this height. So here the height is bigger, but area is small. But in the flat spring, we have a small height, but very big area. Area is big. So then we use a flat spring. So this area is big, but height is this one. So this is an area. But if you see here, as this is the round shape, and if you count this cross section, that area is smaller than the flat spring, but the height is this one. Height is long, the length is bigger. So we are using a helical springs. Both are used in automotive engineering. Okay, how to draw them? In reality, that looks like something like this. We have also pitch here, and it looks like a threading to draw the threading, but it's not a threading, but it has a pitch and direction. Okay, so inclined line, and that might be, the cross section might be rounded shape, round wire spring, and square one. So that's also wiring, but that is a square shape. And in the reality, that might be drawn like this, but to draw this one is difficult. So the simplification is needed. What we do is we can draw 2 rounds only, or 1 round and 2 elements here, and 1 or 2 elements here. In between, we are using phantom line. Phantom line means like a center line, but with 2 dots here. So that phantom line is used on top side and a lower side here. That is allowed. So that's usual way. Okay, so usually we are using is this one. In very big, or in diagrams, in simpler or equipments, you can show this kind of schematic representation also. Schematic representation of 2 types. One side is the flat one. Okay, so both 2 tips are flat one, schematic compression spring and schematic tension springs. And that one is with hook, comes with hook to in both sides. Okay, so that works for the tension. The force acts like this, but this one is hooks are fixed somewhere, and this side is different, so forces works like this way. Okay, so when we use a flat spring, when we have a small height, as I told you, the height is only this 22, and the very wide area is big, so it's kind of resistor. Okay, so we call it resistor in Russian, resistor. Okay, this kind of springs are used in mechanical engineering, and it's drawn like this way. Okay, and in the engineering drawing.